All right. Okay, so my point with this, this information is quite a long way through in our textbook. So we will come back and do it again later in the semester. However, if you look closely at your guidelines for your physical activity log, one of the things that I want you to be able to do is identify intensity, because the guideline, the health guideline says 150 minutes of moderate aerobic work or 75 minutes of vigorous aerobic work or some combination thereof. So you've not only got to be able to identify what is aerobic and what is anaerobic, you also have to be able to identify intensity so that you can show me how you are meeting the health guideline, right? Intensity is key. We're gonna repeat this over and over and over again during the semester. Intensity is crucial. If you want to meet your goals, intensity is the ultimate key. Right? If you get the intensity wrong on the training program, you will not meet the goal of the program. So it's one of the most crucial principles, ideas in XPhys for you to get. Right? It's one of the basic fundamental ideas, and it's really, really important. So my goal today is to give you that information briefly so that you can start thinking about it, start trying to apply it in your physical activity logging class so that I can see some attempt at showing some understanding of intensity at midterm so that then I can give you some feedback and I know where to go when we cover it again in class. What do I want to emphasize? How do I want to help you out with this? Is that right? So, intensity then is just the technical term for how hard you're working. What's the workload for what you're doing? All right? So today we're going to talk about how do we measure intensity when we're doing aerobic work, because that's the thing you've got to transfer to your physical activity log. It's different if you're doing anaerobic. If you're doing resistance work, you wouldn't probably use many of these measures. All right? There are other ways of telling how hard you're working if you're down in the max pack. All right? So the first option you've got, my personal preference, my favorite, is heart rate. And the reason it's my favorite is because it's easy to take. It can be free, or you can buy a heart rate watch, and these days they're available from not very much money up to lots and lots of money. A lot of you have Fitbits or other kinds of watches that will pick up heart rate. There are free apps for your phone where you can stick your finger on the camera and it will give you your heart rate. So it's very easy, it's cheap, and it's accurate, right? It is highly responsive to anything you're doing, heart rate. If you're upset, heart rate goes up. If you're sick, heart rate goes up. If you move, heart rate goes up. Right? It's very sensitive and it's easy to measure. So I like it a lot. It gives me immediate feedback about what I'm doing in ways some of the others don't. But here are the equations that Dr. Barlow was mentioning. All right? The simple one is 220 minus your age. It's a very rough guesstimate of your heart rate max. But it's very, very easy. We can all hopefully subtract our age from 220 without a piece of paper or a calculator. Yes, sir.
Out of all the numbers, why 220?
I don't know the answer to that.
Oh, these are pretty accurate.
At some point, there would have been a lot of work done on that number to work out what's the correct number to subtract your age from, but I honestly, no idea. It would be way, way back in the history. More recently though, we've got some newer ones, and there are several different versions of this. If you look online, sometimes it's 208, sometimes I've seen one that's 206. This one, 207 minus 0.7 times your age, is still a guesstimate, right? The only way to get a true measure is to be on a machine tied up to the computer, right? But these will give you, for most of you, most of the time, a guesstimate is good enough, okay? Unless you're working with world-class athletes, you really don't need to be more accurate than this. The problem with this one is, I don't know about you, but I can't do 0.7 times my age in my head. I at least need a sheet of paper, right? So 220 minus my age is a lot easier. 207 minus 0.7 times your age is a bit more accurate. The most accurate is going to do a stress test and you'll have ECG pads, and you'll get a true max heart rate on a stress test, right? So when you've got an estimate of what your max is, then your intensity is not your max, right? Your intensity is what percentage of the max are you going to work at? Because max heart rate is the point where you fall flat on your face, right? I can't work if I'm falling flat on my face, okay? So I don't work at max heart rate, I work at a percentage of my max heart rate. So the intensity measure is what is the percentage that I'm working at. Am I working at 50%, 60%, 75%, 85%, 96%? It's starting to get really difficult. Not very many of us want to be working at 96% max heart rate. Very, very uncomfortable. Right? That is hard, hard, hard. Okay? The good thing about heart rate, because we're also going to talk about VO2 max, is that it has a linear relationship with VO2 max. So my maximum oxygen consumption is linearly related to what is going on with my heart rate. Right? The higher my heart rate, the more oxygen, but they're not the same number. So when you look at this graph, what you have to remember is oftentimes when you look at training programs or you read research or you're reading a coaching article, the intensity measure they'll give you might be VO2 peak or VO2 max, right? So 50% VO2 max is not 50% of my max heart rate. And that's important to remember, all right? They're linear, but they're off kilter a little bit, right? So 50% VO2 is about 70% heart rate. Once I get up here, my max heart rate is my 100% VO2 max. But on the way up, they're different. Yes, sir?
Okay, so you know how you said that you calculate your max, your HR max?
Yes.
Is there a possibility that somebody could go above like their calculated max?
Yeah, because it's an estimate, You can go above or under. So when I was younger, the estimate actually overestimated my max heart rate. And so I was always working a little bit hard. I was always like, why is this so hard? Like everybody else is not working this hard. And then when we did an actual stress test at college, I found out that the equation overestimates my max.
So it's not like a bad thing if it's higher or lower?
No, it would be an individual difference.
Oh.
It's just, you know, again, you've got to take it as an estimate. So if you use this, 220 minus your age, and you set someone a program at 75% of their max heart rate, you would expect certain adaptations to occur, right? If those adaptations aren't occurring the way you would expect, one of the things you might want to question is it 75% workload? Because if this estimated incorrectly, then the workload could be wrong for that person. Right? 220 is the top. I mean, you're not within reason. I mean, you might have some people who are 223 or 224, but people's max heart rate, I mean, you couldn't, this number isn't going to be 240. Right? And the other thing to think about that's interesting is it's a number minus your age. So every year you get older, technically your max heart rate comes down. Right? Your ability for workload gets lower as you get older. So you have to keep doing the adjustments in the numbers continuously with your program. Right? So for my money, I don't know even why we use anything else, to be quite frank. It's so simple, it's so straightforward. However, there are other measures out there that you're going to see. So let's have a look. This is the other one that Dr. Barlow was talking about, heart rate reserve. Right? Heart rate reserve is useful because it is a way of using heart rate to estimate VO2. So if you don't want to do the change in numbers because your program was written in percentage VO2, I'm working at a percentage of my maximum oxygen consumption. And many programs use those numbers. Then you can use heart rate reserve to estimate VO2. Right? So it's called the Carvonen method. And to calculate your heart rate reserve, you want to have your estimated heart rate max, and you subtract your heart rate at rest. Right? Be careful taking your heart rate at rest. It's very sensitive, so you have to have been resting for quite a while. That's why I said in class the other day, the best time to take your heart rate is first thing in the morning when the alarm goes off, before you sit up in bed. Because that's the closest thing you'll get to a true resting heart rate throughout the whole day. Right? So you take your heart rate max, you subtract your heart rate at rest, and that gives you your heart rate reserve. And again, it's going to adjust with training because your heart rate max only adjusts with your age, but your heart rate at rest should get lower as you get fitter. So your heart rate reserve gets larger. All right? So this is pretty easy. Personally, I don't know why not just stick to percentage heart rate, but, you know, people, it sometimes is simpler to think about VO2 max rather than try to do the switch in the calculation, as I said. So you want, it gives you a target heart rate, so for both these measures, you can set a target heart rate range. It is a better idea than a target heart rate because your heart rate is never the same beat to beat, minute to minute. So if you have a heart rate watch or another training tool, you don't really want to say, I'm going to train at 160 beats per minute, because you can't, right? It's much better to set a window. I want to keep my heart rate within this window. And we'll talk about that as we go through the semester. All right, so another one you're going to see is something we call an RPE. It's a rating of perceived exertion. This particular one is a Borg scale 6 to 20. There are RPE scales that run 1 to 10. There's several different versions of them. Right? And a Borg scale, an RPE scale, is your perception of how hard you're working. So if you're down on the treadmill and I hold up 6 through 20, you have to tell me which number you think you're running at. Okay? Interestingly, if you use it with people who are experienced exercisers, this is actually very accurate. Which I always find hard to believe, but the research clearly shows that it's very accurate. However, you can't use this with a beginner, because it's my perception of how hard I'm working. And beginners don't know how hard they're working, and they often think they're working really, really hard when they're walking down the road, right? So it doesn't work until you've got enough experience at moving to understand what working hard means or when you're slacking off. Does that make sense? All right, so you've got to be a little bit wary. It's a useful tool because all you do is hold up a card that says 6 through 20, what number are you working at? But you can't use it with your beginners. You've got to teach your beginners how to take their heart rate. All right? So the lower the number, the less work you're doing. Okay. All right. So often if you walk into a gym, they may have a Borg scale up on the wall so that when you're running on the treadmill or something, you can have an estimate of how hard you're working. I wouldn't use it for myself, personally, because I don't trust how honest I would be with myself. Right? If I was feeling lazy, I could kid myself I'm working at 16 or 17 when actually I'm only working at 12. You know, that's why I like my heart rate, because that doesn't lie. If I'm being lazy, my watch is going beep, 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 beep. You're under your training zone. Move your arms, you lazy move. All right? So I like my heart rate watch because I can't cheat unless I absolutely decide I'm going to. Okay? But I'm not sure, personally, I'm not sure that I would trust myself with a Borg scale. But as I say, the research says it's highly reliable. Okay? So you will see those in the literature and around in gyms. The other option you've got for aerobic work is METs. And they have become quite popular in the literature as an intensity measure. My concern with trying to use it with the general population is you've got to have a pretty good understanding of what's going on to be able to represent what you're doing in METs. And I've seen recently, even in things like yoga magazines or, you know, on-the-shelf aerobic magazines or running magazines, that they're using METs. And I think that's a little too sophisticated for the general public. However, it is popular right now. One MET is how much oxygen you need to sit here at rest. So it's all about oxygen consumption, not how much you're breathing in, how much you're using at the tissue level, which is why I'm like, well, how would the general public know about that? Okay? So when you're sitting here not doing anything, how much oxygen does that take? Remember we said yesterday, this is aerobic work, right? So how much oxygen do you need to do this level of aerobic work? Not very much for most people, all right? So that's one MET. So your intensity measure becomes how much more oxygen do I need to do the work I'm doing now? So it's greater than I need to sit down by how much? Okay? Resting oxygen consumption, on average, it's a real average, because there's no such thing as an average person. The bigger you are, the more muscle you have, the larger your oxygen consumption, right? But on average, it's about 3.5 milliliters per kilogram per minute. So anything more than that, METs goes up, okay? So 3 METs is considered to be on average about 10.5 milliliters per kilogram per minute. So 3 METs means you're working 3 times harder than you're working when you're sitting down. Does that make sense? The higher the MET number, the harder the work you're doing, the higher the intensity. Okay? There are limitations. Again, I think the first limitation is that it's a similar setup to a Borg scale. I have to know what 3 times harder than sitting down is, which I think is a problem with the general population, all right? The other problem is that, as you'll see when we do chapters later on and we look at what happens physiologically when we go up in altitude, or when it's hot or when it's cold, METs doesn't take into account that, right? So you work much harder at 10,000 feet than you do at sea level, but the METs is, the program's still going to say 3 METs, but 3 METs is very different at altitude. Okay. So it's good for a training guideline, I think, if you know what you're doing. It doesn't really take into account the fact that the fitter you get, the less oxygen you're going to use to do the same amount of work. So again, it's very popular, it's kind of in right now, you'll see it around a lot. I still don't know why you're going to do percentage heart rate max. It can't lie. It cannot lie. Especially if you have a monitor. I mean, if you're taking your pulse, you might miscalculate it a bit, but it doesn't, heart rate doesn't lie. So I don't know, it just seems to me to complicate the picture to put in all these other measures, right? I'm a simple little girl. I like things black and white. I don't like to complicate my life. So I put a table in here to try to help out so that you can see the differences between the various ones, and I've never put the METs on here, so let me just stick the METs on the side here. All right, if you are working at a moderate level, your MET number should be 3 to 6, right? Anything over 6 is considered vigorous. So here you can see if I'm going to work at a moderate level of aerobic work, then my heart rate training zone would be somewhere between 60 and 79% of my max heart rate. Right? It would be 50 to 74% of my VO2 max, and I can use heart rate reserve to estimate that. It would be 12 to 13 on an RPE Borg scale, a 6 through 20 scale. And it would be 3 to 6 meds. Right? So you can see the comparison across. There's no rules about which one you use for your log. You can use whichever version of intensity you want. But I want to see you starting to think about what intensity am I working at, because it's a crucial, crucial key to success with training program. Right? If you walk away with nothing else at the end of the semester, you need to understand intensity. Right? The rest of it is great, and it will be helpful if you get it. But if you don't remember sliding filament theory in 2 years' time, it's not going to kill you as a coach. But if you can't remember what intensity you should be setting your program at, you're going to have a problem. Okay? Question. As I said, we are going to do this material again in class, but it's quite a long way down the road. And in the past, I think I have left it too late to start introducing this material, and then I get frustrated when I get your logs in because you're all talking nonsense or you're ignoring intensity altogether, and I want to do a better job on that this semester. Okay? Excellent. Thank you very much. I have an idea of timetable, so keep an eye out on the blackboard. I'll put that up. And then, as I said, get in touch with Dr. Barlow, get in touch with Jenna. If something is not going to work for you, this is your grade, let me know. Because as far as I'm concerned, I'm done now. I'm out of this. Okay? All right. Thank you. She can She's got 5 to 8 o'clock any night of the week, and 7 o'clock to 1 o'clock on a Tuesday. So I'll put these out today, and so if you, if it really needs to be a weekend, I would just email me directly and say, sorry, but this is going to be. How are you doing trying to eat a few more calories? It's hard, isn't it?
Yeah, it is hard.
Yeah.
You're gonna put up the quiz at 5?
6.
6, alright.
You didn't have school for a while, right?
And so,
No, this was, I just,
Tuesday.
this is, yeah, this is just information you need, and then next week we'll cover the data again. Let's turn that camera off.